Now students, I'm going to discuss one of the most important and challenging problems from definite integral. This is just an introduction to calculus, how calculus can be interesting. Particularly the indefinite integral part of it is very challenging because while we are finding out integration means what? We are trying to find out a function whose derivative is the given function. In other words, we want to find out whose derivative is root of tan x dx. Now this problem is not a very easy problem. It's one of the most difficult problems at the plus 12 level. Okay. So now I'm going to, generally this problem is solved in most of the textbooks in one particular manner. But I'm going to give you two different ways of solving this particular problem. That is the specialty of today's lecture. Now, first of all, let us familiarize ourselves with the standard method of solving this problem. The standard method starts with this. In a standard method, we use a substitution called tan x is equal to t square. So this substitution is a standard substitution for this problem. And as all of you know, whenever you substitute, you have to find its derivative. So it becomes sec square x dx. This is equal to derivative of 2t, t square is 2t dt, right? Now, if I make this kind of substitution in the problem, now the problem transforms into this square root of t square, because tan x is t square, and this dx is actually what? It is 2t upon sec square x, correct? So I'm just taking this sec square x on this side and isolating dx, so that this dx can be replaced by 2t upon sec square x. But as a rule of substitution, we cannot keep any expression in terms of the old variable called x. So I'll have to eliminate sec square x as well, right? So if I want to do that, then I got a very simple equation. All of you know from trigonometry that sec square x is equal to 1 plus tan square x. So now with that, this problem becomes root of t square. I'm going to write t, and this will be what? 2t, and this sec square x becomes 1 plus t square dt. Okay. So now you have this problem transformed into this new problem. Now what is this new problem? Integral of 2t square dt divided by 1 plus t square, correct? So that root tan x problem is now, after substitution and change of variable, we have converted into this problem. Now this problem I have to solve, okay? Now, I'm sorry, this sec square x is not t square, because it is not t square, it should be because tan x is t square, so sec square x is 1 plus tan square x, right? And tan x is t square, therefore it is 1 plus t square raised to 2, so that amounts to 1 plus t raised to 4. So here I made a mistake. It should be 2t upon 1 plus t raised to 4. So here also it has to be the same thing. Instead of 2, this has to be t raised to 4. Is that understood? I'll repeat again. Tan x is t square. So sec square x dx is 2t dt. Therefore dx is 2t upon sec square x. But sec square x is 1 plus tan square x. Therefore 1 plus t square square is equal to 1 plus t raised to 4. Now this is our problem now. Okay. So we have transformed this problem into this problem. So if we can solve this problem, our job is done, provided we resubstitute again at the end of the solution. Okay. So I'm going to remove this part of the problem now. Okay. Now let us get on with this problem. Now 2t square upon 1 plus t raised to 4. Now this can be written as, now this is a very, very important and very crucial step, and this very ingenious method of doing it, So 2t square can be actually written as t square, plus t square. Okay. So here you can write 1 plus t square, and here you can write minus 1 plus t square. So basically I'm just writing t square plus t square as 2t square. This 1 is anyway going to get cancelled. Okay. so that this is divided by 1 plus t raised to 4 dt. Okay. Now this ingenious addition in this problem will make it very interesting. Now see, I'm going to put a bracket around the last two terms. That means 1 plus t square in one bracket minus this bracket will contain 1 minus t square. Correct? Because I have taken minus sign common, this plus sign will become minus, and now I have two problems here. Two terms here, and the problem is now reduced to this, right? Now we are going to turn this problem into two different problems. So that means I'm going to write it like this: 1 plus t square upon 1 plus t raised to 4 dt minus 1 minus t square upon 1 plus t raised to 4. Interesting, right? So this one problem has now given rise to two different problems. Okay. Now the next step is another very, very crucial and very ingenious method. What I'm going to do is I'm going to divide both numerator and denominator by t square in both the cases. So dividing numerator as well as denominator by t square. So what will happen? Let's see. Very interesting. So if I divide numerator by t square, what will happen? Every term is going to be divided by t square. So this 1 becomes 1 upon t square. This t square becomes 1. Now here this becomes 1 upon t square, and this t raised to 4 reduces to t square. Correct? So I'm dividing every term by t square and you get this term, right? So this is 1. Second term also I'm going to do the same thing. So it becomes 1 upon t square minus 1 divided by, denominator remains same, 1 upon t square plus t square dt. Now you will be wondering, what is the use of all this manipulation? Because it looks like quite acrobatic steps. Fine. So the terms in t are literally dancing from numerator to denominator, numerator to denominator. What is the advantage of this? Remember one thing, that there is one identity in algebra, which is very interesting identity. The identity says that a square plus b square can be written in two different forms. Now, so a square plus b square can be written as a plus b bracket square minus 2ab. Correct? It's the same thing. But the same thing can be written as a minus b square plus 4ab. Correct? I'm sorry, plus 2ab. Plus 2ab. Correct? Now, this is the greatest advantage, and this advantage I'm going to use for this denominator. Right? Now, this denominator is like a square plus b square. This a square plus b square can be written as like this or like this. But I have to be very, very careful about choosing which expression should be used in which integral. Now, that depends upon the sign in the numerator. Now, in the numerator, we have 1 upon t square plus 1. And in the denominator, we have this. So, will it be this or this? So, the rule is very simple. If it is plus sign here, use the minus representation. Okay? So, now again, I am going to remove this. So, now let us see. So numerator remains same. So 1 upon t square plus 1 divided by, now 1 upon t square plus t square can be written as 1 upon t minus t bracket square plus 2 t multiplied by 1 upon t ab. So this is a, this is b. Correct? Whereas in the second, what am I going to do is this. I'm going to write keep the numerator as it is, no change in that. Okay? But in the denominator, I'm going to substitute 1 upon t plus t bracket square minus 2 times t into 1 upon t. But t into 1 upon t will cancel each other, obviously. So this becomes only 2. Here also it becomes only 2. Now, I will rewrite the problem like this. So it is 1 plus 1 upon t square dt divided by, see, because it's a square, even if I interchange the order, it makes no difference. So that is t minus 1 upon t bracket square plus 2. Okay? Plus, here also I'm going to write 1 upon t square minus 1 dt divided by t plus 1 upon t bracket square minus 2. So these are the two integrals that we are dealing. Now what is the use of all this? The use is very simple. If you look at this expression, इसका डेरिवेटिव ये है, t का डेरिवेटिव 1 आता है और माइनस 1 अपॉन t का डेरिवेटिव आता है 1 अपॉन टी स्क्वायर. Whereas इसका डेरिवेटिव ये है, क्योंकि इसमें प्लस साइन है तो बीच पे का साइन माइनस हो जाता है. In other words, here I am going to put t minus 1 upon t as some variable z. Okay. Now therefore इसका डेरिवेटिव आएगा 1 plus 1 upon t square dt. This will reduce to what? dz. Okay. Now here I am going to substitute, let t plus 1 upon t, let it be equal to w. So therefore its derivative will be 1 minus 1 upon t square. That will become dw. Of course, dt here, dt, right, is equal to dw. Now these two problems are almost solved, because now I can write it like this. See here. So now this problem becomes now what? It is 1 plus 1 upon t square. So this entire expression is now replaced by dz. Entire expression is replaced by dz. And this expression is replaced by z square plus 2. See how simple it has become? In the same way, here, this expression becomes dw. And this expression becomes w square minus 2. Now, those of you who are familiar with the formulas of integration, these are standard integrals. Now, what are the standard integrals? I'll tell you one thing. dx upon x square plus a square. The integral is 1 upon a tan inverse of x upon a. This is the answer. Of course, that omnipresent constant of integration has to be there. Okay. Now this integral, that is 1 upon dx divided by x square minus a square, is 1 upon 2a log of x plus a divided by x minus a plus c. Correct? So these are the two laws. These are the two standard integrals which we'll apply here, and then problem is solved. So now what is the answer here? Let us see. So this is equal to 1 upon a. This is a square, remember. So if it is a square, then what is a? A is the square root of 2. So 1 upon root 2 tan inverse of z by root 2. Correct? Plus, this will become 1 upon 2a. So 1 upon 2a, I'm sorry, no integral sign here. 1 upon 2a, that is 1 upon 2 root 2 log of w minus root 2 divided by w plus root 2. Okay? Plus c. Now what is left is very simple. You just replace this z by its original value and w by its original value. What is z? So let us write. Z is, if you remember what was z? Z was t minus 1 upon t. T minus 1 upon t, correct? Divided by root 2. Okay? This was the answer. Plus, here it is 1 upon 2 root 2 log of, this w was t plus 1 upon t minus root 2 and divided by t plus 1 upon t plus root 2. Okay? Plus c. Of course, this can be further simplified as 1 upon this root 2, and this root 2 becomes 1 upon 2. So this becomes t square minus 1 upon t, right? And this becomes 1 upon 2 root 2 log of this becomes t square plus 1 minus root 2t divided by t square plus 1 plus root 2t plus c. The last step, I leave it to you. You have to replace t by what? Tan x, right? So t square is actually tan x. So it is tan x minus 1 upon tan x. This is tan x plus 1 minus 2 root t tan x. So replace t by tan x and the problem is over. Okay. Now, this is a very, very long and quite difficult method of solving a problem. But it introduces two very important tricks. One is use of this. A square plus b square can be written in two different ways, right? That is the crux of this problem. Okay. I hope you have understood the solution of this problem. Okay. Now let us go to the next method. We have seen the standard method of solving this problem, which is given in almost all the textbooks. There's nothing new about it. And of course, this method was also important because it uses two very ingenious methods of solving a problem. But I have found out that this problem can be solved without the substitution tan x is equal to t square. Now, how that can be done? Let us see. So, this root tan x can be written as sin x upon cos x. This is the standard relation. Everybody knows this. That tan x is a ratio of sin x upon cos x. Okay? Fine. So, what am I going to now? This will be like this, I will multiply and divide numerator as well as denominator by sin x. So here also I am writing sin x, here also I am writing sin x dx. Now you will be wondering, what am I doing? But this has become now sin square x. So now this can be free from this radical sign. So it will come out of the radical sign. So now this has become integral of sin x divided by square root of sin x cos x. So far so good, right? So sin x cos x can be written sin x upon root of sin x cos x. Now I am going to do something very interesting. Let us see. I am going to write this as, I will write here half. Now if I am writing half, I am changing the value. So I am going to write here 2 sin x. So I am writing multiplying and dividing by 2, right? Essentially, I am not doing any changes. And if you recall, in trigonometry, there is a formula. That formula is like this. Sin 2x is equal to 2 sin x cos x. This is a very famous formula from trigonometry. Okay? So this sin x cos x can be replaced by sin x cos x can be replaced by 1 upon 2 sin of 2x. Correct? So this sin x cos x I am going to replace it by what? 1 upon 2 sin of 2x dx. Quite easy. You should understand. So now this half in the denominator will go in the numerator with the root sign. So it will be root 2 upon 2, but root 2 upon 2 will become 1 upon root 2, right? And this becomes 2 sin x. This 2 sin x divided by square root of sin of 2x. So far so good. What am I going to do with this? Now that is the most interesting step. So next step is going to be crucial. It's a 5-star step. The most difficult step to understand. What am I going to do is this? Let us see. Now this step, what am I going to do? As I did in the last time also, this will be 2 sin x, no? So 2 sin x can be written as sin x plus cos x and sin x minus cos x, which means basically I am not changing anything. Sin x plus sin x is 2 sin x and cos x minus cos x anyway cancels, right? So this is divided by square root of sin 2x dx. Now you will be wondering, why am I doing it? Because this sine 2x is a very interesting phenomena because sine 2x can be written in two different ways. One is sin x plus cos x bracket square, right? Sin x plus cos x bracket square minus, so sin 2x is what? If you expand this, what will happen? Sin square x plus cos square x, which is 1, plus 2 sin x cos x, right? So therefore, minus 1. So sin square x plus cos square x, which is 1, which will get cancelled. What will be left is the middle term, which is 2 sin x cos x, but 2 sin x cos x is sin 2x. Okay? But sin 2x can also be written as 1 minus sin x minus cos x bracket square. Just verify. Sin square x plus cos square, if we expand this, sin square x plus cos square x will become 1. That will get cancelled with 1. Middle term will be minus 2 sin x cos x. Along with minus sign, it will become plus 2 sin x cos x, which is nothing but sin 2x. Followed? Now you will understand why I have converted this one problem into these two steps. So now I will again convert this problem into two problems. One is sin x plus cos x dx, and denominator root of sin 2x I am going to write by this method. That means it is root of 1 minus sin x minus cos x bracket square. What is the advantage of doing this? Simple. इसका डेरिवेटिव ये है, sin x का डेरिवेटिव cos x है और माइनस cos x का डेरिवेटिव sin x है. मतलब ये जो फंक्शन है, ये जो एक्सप्रेशन है, उसका डेरिवेटिव मैंने इधर एडजस्ट किया. ओके, प्लस नाउ हियर आई एम गोइंग टू राइट sin x minus cos x dx divided by square root of, this will become sin x plus cos x bracket square minus 1. Again, what is the derivative of sin x? It is cos x. And what is the derivative of cos x? Minus sin x. So there is a slight difference. I don't want sin x minus cos x. I want cos x minus sin x. That can be adjusted. But that doesn't make any problem at all, because this will become now sin x plus cos x dx divided by under root 1 minus sin x minus cos x bracket square, and this plus sign I want to make it minus, and this I will interchange. Cos x minus sin x divided by under root sin x plus cos x bracket square minus 1 dx. Now you can clearly see derivative of this expression is this. Derivative of sin x is cos x and derivative of minus cos x is sin x. Derivative of sin x is cos x, derivative of cos x is minus sin x, correct? So if I write this as t, this becomes dt, correct? So sin x minus cos x, if it is t, then sin x plus cos x becomes dt, dx becomes dt, correct? So now this becomes dt upon square root of 1 minus t square, which is a standard integral operator, right? And minus, here if I substitute this as say w, then this becomes dw upon square root of w square minus 1. Those of you who are familiar with integration formulas, you know this can be solved further because these are all standard integrals, correct? So that is the end of this problem. Remember, more than remembering the solution of this problem, you have to understand the idea behind solving this problem, So writing one expression in two different ways can give you a fantastic method of solving an integration problem, right? That is the crux of the matter. I would advise students to just read or watch this problem solution once, erase it completely and try to solve it on your own. As long as you can solve it on your own, you understood it. Until then, You have not understood it. So you can solve, you should be able to solve it without referring to the solution, right? That is the end of it. And this problem will teach you lot of things. And these methods can be applied to not one, but many other problems. Okay? Fine. Thank you very much.